All right, everybody. For bell work today is an application that we ended last class on. I'll give you 3 minutes and then we'll go over it. Yeah.
Are we gonna have like a final, like over
Yes.
everything?
Well, every test is over everything.
Huh?
Every test is cumulative. So, yeah.
Oh, yeah. So is it just gonna be like a test of our last unit?
Yeah.
Oh, okay.
And also over everything.
Oh, there's no final.
The final will be the last unit test. Yeah.
Okay.
Yes. Which will cover everything, just like every test does. And every quiz.
So it won't be like one of those finals where there's like 15 questions on every single thing.
It'll be more weighted to the last unit.
So it'll just be like what we've been doing for our units.
Exactly. I think that's Mason. Is that correct? Mason, winner, winner, chicken dinner. Mason, what is A for our problem? Give it a guess. It is 10,000. What is P?
I mean.
It's what you are trying to find. So question mark. Yeah. What is R? 0.015. Okay. So again, note that that's 0.015, not 1.5. What is N? 12. And what's T? 5. So we want to find what's the principal, what's the starting amount that we have to have so that we finish with $10,000 after saving for 5 years. Plug in our numbers. And then you can actually solve that equation in 2 steps. We just gotta simplify, because this is just a number. Find out what that is in the calculator. So what is parentheses 1 plus 0.015 divided by 12 raised to the 60th power?
I'm sorry. 1.0777.
Yep.
You already have it.
And then to solve this and get p by itself, what's the last thing we need to do? Divide. That's right. $9,277.87.
Hang on, I got it backwards.
So if you put that in the bank, 5 years later, you will have $10,000. Basically make what, $730? Yay?
Yay.
Yay. I'm waiting. I'm good. Everyone else okay? So any of those word problems can sometimes be a little spooky scary because they'll give you a lot of information. But if you approach it the same way, just write out the stuff it tells you. Write what your unknown is. Write the equation, which generally is either given to you or it's in your notes. Plug in your numbers and solve. It will make it easier for you. Have I done this before for you? Guess. That's just rules to live by. Write your givens, unknown, equation, substitute, solve. Use that in your science class, your math classes, this class, whatever math you take next year. Same approach. Okay, last call for the bell work. Okay, let's do it. Today, we're going to do logarithms. This lesson will probably take today and tomorrow, or maybe we'll lecture today and then tomorrow will be a work day. The homework is not due till Thursday.
See, this was the point in honors algebra too, when I was like,
This is what most people struggle with.
let's not.
Really, the most important thing on this success criteria list is the first one. If you can do the first one, you can do the rest of these. So if you pay attention for the first 15 to 20 minutes of class, I think you'll be okay this unit. If, on the other hand, you do not pay attention for the first 15 to 20 minutes, then you maybe have a side conversation between two people, then you will be lost for the rest of this unit. You know what I'm saying? If you pay attention to the beginning of this unit, it's not so bad. If you miss the beginning, it's awful.
Oh, let me pull this ahead.
This is the beginning.
Of the end.
You ready? A logarithmic function is written like this, where you have a function of a logarithm with some base a, which is like it could be any constant, so long as it's positive and not equal to 1. To be honest, it could be equal to 1. No, could it be equal to 1? 1 to the what power? Only in certain circumstances can it be 1. You have some positive number x. What this means, y, your output, will be the log base a of x, if and only if x is equal to a to the y power. That's the most important thing you will ever write down in your entire life. That right there. You should get that tattooed on the back of your hand. A logarithm is just a what power function. It is asking a to what power a to what power gives me the answer x. That's what a logarithm is. A to the what power gives me the answer x. So whenever you see a logarithm, you should just say that is a what power function. Everyone okay on this slide? The most important slide that you'll ever see in your entire life. You want to cherish it a little bit longer? Look at that color of purple. Is that like a lavender? Would you say? Or like a puce? You think it's a puce? I don't know what color puce is. What color is puce? No, it's not puce at all. That's puce. It's like a lavender. That okay, you spell lavender with an E right there. It's not quite a lavender either. What color is that?
You're not.
Extra credit for anyone who finds what color that is.
Purple.
Not in this class, but your seminar teacher will give you extra credit.
No, she won't.
Yeah, I'll talk to him.
She'd rather like thrive.
Okay,
Just because I was in her class.
this is your first questions on WebAside. You do not need a calculator to do these. If we want to find out what is f of x of log base 2 of x, when f is 32, you do this like you would normally. We're just going to replace x with 32. What this question is asking you to find is 2 to the what power is 32. How many times do you have to multiply 2 by itself until you get the answer 32? Squared, 4, 8, 16, 32, 6. Because 2 squared is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. Wait, 4, 8, 16, 32. No, it's 5. It's 5. It is 5. It's 5. I said, it's a good thing we checked that together. It's 5. There we go. Let's double check that one more time. 2 squared is 4, 8, 16, 32.
It's 5.
5. It's 5.
Are you sure it's not 6?
I am now positive because 2 to the 6th is 64. And then 2 to the 7th is 128. 2 to the 8th is 256. 512, 1024,
Was 2 to
2048,
was 2 to the 22nd.
4096. What?
You're pretty smart.
I can do doubling a lot.
Yeah.
All right, yay,
All
happy?
you gotta do is play 2048 or whatever that game is.
I've seen that game. I've never played it.
Really?
All right, your turn.
We play games.
So I will start you out on for A and B. A is asking if you plug in 10,000 for X, we're asking 10 to the what power is 10,000. Number 2 is saying log. Oh, hold on. I didn't format that correctly. Let me change everything about myself. 1 second. Okay, there we go. That's formatted correctly. And what that is asking you to do, log base 10 of 10,000 is asking 10 to the what power is 10,000. How many times do you have to multiply 10 by itself till you get to 10,000? Number B, letter B, is asking 3 to the what power is 1? C and D, I'll let you set up yourself. I'll give you 3 minutes to do these 4 problems, and then we'll go over. This is the most important thing you'll do in school this year. In your entire life. I was gonna sell it short, but to be honest, it is the most important thing you'll do in your whole life. This slide right here.
I mean, I already set up my tattoo appointment.
If you tell them that you're getting it for Mr. Lake, they'll do it for free.
Oh, really?
Yes,
Where? In the trailer?
just anywhere in Topeka. To be honest, anywhere in Kansas. Like if you go to Manhattan, get a tattoo of, log base A of X is equal to Y if and only if A to the Y equals X. And say, I'm getting that tattoo for Mr. Lake. I'm like, oh yeah, okay.
What's your tattoo?
I mean, I didn't need to get a tattoo because it's tattooed on my soul, on my heart. Had a surgery, they cut me open, tattooed it on the heart. That way I'd always have it.
Pictures of the
So where's the scar? Where's the scar?
scar.
I
can't
can't
show it.
show you the scar. Just trust me that I had surgery where they cracked open my sternum, got to my heart and tattooed my heart. I would not lie about that.
I believe you.
That was cool.
Trying to
All
remember.
that's you could say.
There is a way to do this in your calculator, by the way. I will show you after we do it by hand. Because to be honest, it's probably easier to do it by hand than on calculator. C and D require you to remember your exponent rules. To be honest, B does as well. B, C, and D are all required to know your exponent rules. So if you look at your notes from Friday with the exponent rules on there, it might help you out. Howdy. All right, you got 15, 20 seconds left. Look at your neighbor's paper, steal any answers that they have. You can look behind you, Kyle. John's got paper. Steal any answers they have that you don't.
Oh.
All right, I will take volunteers because this is a little tricky. 10 to the what power is 10,000? How many times? It is 4. You need to multiply 10 by itself 4 times and you get 10,000. Because 10 squared is 100, times 10 is 1,000, times 10 is 10,000. Now you keep going. 3 to the what power is 1? 0. Anything to the 0 power is 1. So the answer here is, I should put equals 4 equals 0. Move this over. All right. C. So we are asking if we plug in 2 for x, log base 4 of 2. What is that equal to? Well, that will be equal to 4 to the what power is 2. Did anybody get this one? 1/2, which is the same as square rooting. Remember that? Yeah, 4 to the 1/2 powers 2, because that's a square root. A third would be a cube root, a fourth is a fourth root, a fifth is a fifth root. Number letter D is also kind of tricky. So this is saying G of 1/100 is log base 10 of 1/100. And so I'm asking 10 to the what power is 1/100? And it's -2. The negative moves it to the denominator, right? And then 10 squared is 100. -2. So your answers are 4, 0, 1/2, -2. Okay, there is a way to do these in your calculator. I have to clear this to show you. Okay, I wasn't gonna clear it then. Yeah. But you don't need a calculator to do these, right? You just have. No, she does. Yeah, absolutely. Actually, don't think she knows. I think the furthest she ever did might have been algebra 2. Same thing with my dad. My dad wanted me to teach him calculus for fun. I'm like, you don't know what you're asking, first of all. Second of all, here's all my video lectures. Go have fun. I don't think he's done any of. I did. Shared them all. I don't think he looked at any of them. Calculus for fun. I mean, I understand that, but you have to you can't just, I guess you could. It'd be hard to learn it, calculus, without a classroom setting. You have structure of doing lectures per day. Okay, anybody need more time? To learn calculus recreationally would require some some consistency. Okay, here's how you do it. All right. Whenever you take a log in your calculator, it will assume it is log base 10. Okay, so for the first one, you can do that just straightforward. Log base 10 of 10,000, I could just do log of 10,000. Answers 4. Last one, where we're doing, move this, screen, wait. Okay, second one, last one, log base 10 of 1/100. You can just do that by hitting the log button, 1/100. Answer is -2. All right, Mr. Lake, what do you do when the log is not 10? And you can do this when the log is 10. It works as well. For any logarithm that's not 10, you can do it by doing log of the amount that you're taking. So log of 1 and divide that by your base. Log of 3. Answer is 0. This one, it's log base 4 of 2. So I do log of 2 divided by log of the base. And you get the answer 1/2, 0.5. So again, if it's log base 10, your calculator assumes that you're doing base 10. If it's not, then you need to do the log of your problem and then divide it by the log of the base. Yay. Yeah, it's all fine. All hunky-dory. Okay. So here are some general properties of logarithms that you could do to save yourself some time where you don't have to reach for a calculator. Log base A of 1 will always be 0 because anything to the 0 power is 1. Right, so if I'm asking A to what power gives me the answer 1, it will be 0. Similarly, log base A of A will always be 1. Because if I say A to the what power is A to the first power is A. So if you have a log base of the same value that you've taken, the answer will be 1. So as a result of that, if you do log base A of A, it'll cancel out and you'll just have X. Similarly, A to the power of log base A of X will cancel out and you'll just have X. Okay, the last one is probably the most important on here for actually doing your work. There will be a web assigned question about this. The only way two logarithms can equal each other is that they have the same base and they have the same value. I should say, if they have the same base, then the x and y's have to be the same value. So it'll, do I even have an example? I think I might have an example of that. Yeah, I have an example of that. I'll show you. But that one is the one that you'll use the most. And that's one they'll ask you about on the ACT all the time. They'll be like, log base 2 of 3 is equal to log base 2 of x plus 5. What does x have to be? Well, you just match. The 2's match, so the 3 and the x plus 5 have to match too. Any of these shocking to you? It's exactly what you would think they would be. Okay, you ready to see it? All right, so for example, log base 2 of x will equal log base 2 of 3 only when, since the bases match, they're both 2, these values have to match as well. So x is 3. Second one says log base 4 of 4 is equal to x. So again, this is asked, this is a what power function. 4 to the what power is 4? 1. So x is 1. So similarly, log base 5 of 5 will cancel out, and this is just x. 7 to the power of log base 7 will cancel out, and this is just 14. And again, you can think of this third one as saying 5 to the what power is 5 to the x. That's what this is asking. 5 to what power is 5 to the x? What's 5 to the x power is 5 to the x power, right? So that's why the answer is x. And again, the most complicated these will get is problems like number 1, where they can put like a whole algebraic expression in here, and then like a whole algebraic expression in here, and you're just going to drop out the logarithms. Basically, they just cancel on each side of the equation, and then you'll solve it using algebra. This one is just a one-step. It cancels out x is 3. But sometimes they'll do like, 3x plus 1 equals 4. And then you have to solve it for x. Yay? All right, we're almost out of the clear then. All right, try these two. This is a 1-minute timer. Okay, you get 1 minute to do these two problems. I'll walk around. If you're stuck at all, just stop me and I'll help you out. That's right. That's right. All right. Can we do it? All right. You need it, it'll be a single number of those. Yeah. Single number of those. Yay. All right, you should have got, that's the first one. Okay, so again, the base here is not written because it is assumed then that the base for both of these is 10. Since they both have the same base, you can basically cancel out the logarithms, and what you have left is that x must be 2. For the next one, 20 to the log base 20 cancels out because again, logs and exponents are inverse operations. And then all you have left is 3. Yay? Does everyone see why the second one cancels out? If not, I'll walk. What this asking, if you did this, you would say 20 to the what power is 3. I don't know what that number is. But whatever that number is, let's say it is, I don't know, let's say it's like -3. That's not the answer, but let's just say it's -3. Then I would take that answer, -3, and I would raise 20 to the -3. But what is 20 to the -3? That's 3. That's what we said, right?
Oh.
Right? So when you do this, you're doing 20 to the what power is 3. It's whatever, I don't care, -3, -2.7. And then you're actually doing 20 to that power. -3, -2.7, whatever. But we know what the answer to that is, right? They told us the answer to that is 3. Okay. All right, the rest of this is now downhill. You're going to have to graph logarithms, which you'll do in a calculator. We'll do that. We'll talk about when the base is e instead of 10, but really that's just a notation thing. And then domain is kind of tricky. Domain is the next part. That's kind of tricky. All right, but let's do the graphing part. If you want to graph these in Desmos, I believe you can just graph it normally. Log base whatever to x of x. Your graph will generally look something like this. Its domain is 0 to infinity, not including 0. It also doesn't include any negative numbers. That's really important, and they ask you about that on the ACT. But it should make sense if you think about it. If we do log base 2 of 0, I am asking 2 to the what power is 0. That is impossible. It is impossible to multiply 2 by itself any number of times and get the answer 0. Right? The lowest you could get it to is like 2 to the 0 power would be 1. But that's not 0 either. Same thing with the negative number. Your x values cannot be negative because, again, that would be impossible. If we do log base 2 of -4, how many times do you have to multiply 2 by itself to get the answer -4? You can't. You cannot multiply a positive number by itself and get a negative number. That's impossible. So that's why your domain will never include 0 and never include negative numbers. Range is -infinity to infinity. It'll go down forever, up forever. Y-intercept will be always 1, 0, assuming it's not translated to the left or right or anything like that. It increases as you go to the right. It's got a vertical asymptote here at the y-axis, because as it gets closer and closer, as you raise 2 to a half and a quarter and a third and all that, your y values will get smaller and smaller. It's continuous. There's no holes in the graph or anything like that. And if you reflect this over the line y equals x, you will get your exponential equation. So if I draw that in here, if you reflect this over this line y equals x, what you'll get is this curve, which will be familiar to you. You seen that curve before? That's a to the x power. That's in your Friday's notes. That's an exponential function. Again, because they're inverses of each other. Every function's inverse is a reflection of it over this diagonal line y equals x. Those are inverses of each other. Logs and exponents. Exponents take a number to a power. Logs ask you what power you have to take a number to. Questions on this slide? Does anybody need more time to write? Okay, yeah, a little bit. You go ahead. Take your time. Where the red line is the line y equals x. Has a slope of 1 and a y-intercept of 0. You can find the inverse of any function by flipping it over the line y equals x, assuming it has an inverse to start with. How about that weather on Sunday? That was pretty good. Had Willow's first birthday party, walked around the zoo. Well, she turns 1 on Tuesday, but we had her party early. Walked around the zoo, fall colors were really nice. It was good.
It was like 70 degrees.
It was.
Yesterday I decided to wear a long sleeve shirt to work. Like, what's wrong with me? I'm foolish. So I kept thinking, it's been so cold. And November, they forget that. Exactly, yeah. Jesus, but also. I felt like that.
All right, anybody else need more time? Okay, try to graph these at either Desmos or your TI-84. I will give you a heads up. To graph this one in the TI-84, it assumes the base is 10, not 2. So to graph this in a TI-84, you have to type in log of x over log of 2. That's how you have to type it in to make it graph properly. The other two you should just be able to type in. I'll give you 3 minutes. Right. Okay, no, I do have to show you how to do in Desmos. I'll show you. Yeah, okay, hold on. Pausing the time. Let me show you how to do this in Desmos. Okay, so in Desmos, you can just type log. To get the base to not be 10, here's what you have to do. You have to hit shift minus sign. That'll do the subscript. Or I believe if you pull up the calculator, then there's a button here. Functions. No, where's the button? Is there a button? No, right here. Okay, yeah, it's like hidden. If you want to do, let's say like log base 4, you can hit shift minus sign or hit 1, 2, 3 or ABC, I should say ABC, and then right here will let you do subscripts. Okay, so see if you could type it in the graph in either Desmos or your TID. Okay, now I'll give you 200. I will walk her in and help. So if you're stuck on how to get the second one, let me know and I'll show you. Yes, that works. Okay, show me how you get it. Oh, yeah, there you go. That used to not exist. Yes, but I believe, actually, I think all the calculators have it. I think I've updated
It's like the one thing I learned.
Well, there you go. I will, thank you for showing. I'll show everybody. Yeah. Yeah, back when I was in school, that did not exist. And I bet you, hold on, which one of these does not have to be? Is it 28? Yeah, 28 does not have it. Just the newer ones. Somebody just showed. Let's see if there's Oh, there it is. You do have it. There it is. That'll let you type it in with the little subscript. Yeah, you can look. Okay? Okay.
That's what we just said.
So you can type it in how I did. While I
That was like
so far up. Yeah. Yeah. Hey, there, we'll give you a box to type in the base, so you don't have to worry about that. Of course, we want to do that in white. Yeah.
Did I almost did it?
But you want to type that in white. Yeah. Type it in.
I wasn't going that fast. I was literally
Math?
That's the icon.
And then X, and down, and now you see a graphic.
Yeah. Is this supposed to look like this?
Yes. Maybe. That looks good. That looks good.
Let me see.
Well, you're graphing all three at the same time.
Yeah.
What you're doing?
Yeah, maybe I
That's
should.
pretty spicy.
That is pretty spicy. Maybe I should.
This is good. That is reversed. It's log X over log 2. That's why it does so easier. The rest. is good. Yay. Yeah. X divide log 2. Yes, and now that'll graph. And that's the table for it. No, it'll start off at any number bigger than 0. So it'll start with 0. Right. So yeah, it'll basically go down forever.
You're right, I bet.
It graphs it.
Yeah, I don't even know what you're seeing.
It's almost a vertical line. It's about okay? Yeah. Good. And then for the second one, hit enter. Okay. So then you type it long.
Man, I tried to listen to something.
We're gonna do this substrate, so now you go back to the number. We want to do substrate 2. Log X 2.
Still out.
There you go.
No, that is not ridiculous.
Good. Yeah. So, yeah.
Honestly, I don't
Okay, last thing I'm gonna show you, thanks to Nolan. Let me show you one last thing.
Thanks, Nolan.
This may not apply to you, but if you have the newest version of the calculators, you do not actually have to do this thing that I've been doing. If you hit math and go down to option A, again, that might not exist in your calculator, but then it'll give you a little box that you can do it. So you could do log base 3 of 1 is 0. Most of my calculators have it. I think there are 3 that don't. But you can use that to graph it and all that, if you graphed it.
So you go to what?
Math,
Oh, I don't even have that button.
math, and then all the way at the bottom, option A.
Oh my gosh.
Why not? I like this too. I didn't know I could do piecewise either.
Who realized that? It was
Nolan.
Good job, Nolan. Good job. Proud of you.
Okay, tomorrow we'll finish out the lecture. It is really short and I usually have most of the hour to work. Friday.